Hello, students. Mr. Turek here. This is for Math 2 Summer School Spring Term Week 1, Day 1. The stuff I didn't cover. I want to at least make an attempt to cover it with you a little bit. So I'm going to pick up at Activity 2.2, material I'm supposed to go over. I'm looking in your student textbook. I'm on page M3-28, and it says, consider a function absolute value of a is equal to 6. So there's two possible solutions. If what is inside parentheses is a positive number, then that would be one solution. And if what is inside the parentheses is a negative number, then you take the negative of that number, and that would be the solution as well. So there work out to be two solutions. A is equal to positive 6, and a is equal to negative 6. This is a kind of worked example that begins on page M3-28 if you happen to have a textbook accessible. And then it goes on and poses the question, well, what if I have instead something like x minus 2, let's say, absolute value is equal to 6? How would you solve that? And so the answer is, well, there's two possibilities. If what inside the absolute value sign is positive, then you could write this without the absolute value sign itself. You could say x minus 2 is equal to 6, and then add 2 to both sides, and isolate the x, and you get x is equal to 8 as an answer. But there's a second possibility here, and that is if everything inside the absolute value sign is actually negative. And so to figure that one out, you could put a minus sign and replace the absolute value symbols with open and closed parentheses. And so minus sign on the outside, x minus 2 close parentheses on the inside, set that equal to 6. Great. Now solve for x. This time you have a minus sign out here in front. If you want, you can use the distributive property, in which case this becomes negative x plus 2 equals 6. Alternatively, works just as well, you could choose to divide both sides by negative 1, in which case you have x minus 2 is equal to negative 6. Now, I kid you not, both of these lead to exactly the same solution. If we go with this first route, I want to solve for x. So I could choose to add x to both sides. And that gives me 2 on the left is equal to x plus 6 on the right. I could then subtract 6 from both sides. 2 minus 6 means negative 4 equals x, and there's my solution. Negative 4 equals x. I'm going to have to scroll like this for you. Had I gone that other choice of first dividing everything by negative 1, now I would choose to add 2 to both sides, and it works out that x, when it's isolated by itself, negative 6 plus 2 is equal to negative 4. And once again, I get the solution. So the order in which you do these math steps isn't critical, as long as you don't violate any of the math rules that you've learned in algebra about distributive property, commutative property, what happens when you divide by 1 or multiply by negative 1. As long as you don't break any of the rules, whatever steps you go through will get you to the correct answer. And it's always a good idea to check it when you're done by plugging your solution into the original equation. So our first solution was x equals 8. 8 minus 2 is 6. Absolute value of 6 is 6. That checks. Our second solution was x equals negative 4. Negative 4 minus 2 is negative 6. And the absolute value of negative 6 is 6. So it checks. On your next page of this activity in your student book, it says solve these linear absolute value equations, show your work. I'm randomly going to pick 3D. which says the absolute value of 2x plus 3 is equal to 0. That's too easy, right? How about I do 3c instead? 3c looks a little more challenging. Absolute value of 3x plus 7, all that within the absolute value sign, is equal to -8. Okay, I would look for two solutions. The first solution is if everything inside the absolute value sign is actually positive. And so I can replace the absolute values with parentheses and now solve it by the usual rules of algebra. This is, well, okay, these parentheses aren't doing anything for me. It just says 3x plus 7 equals -8. I want to solve for x. I would choose to subtract 7 from both sides. Watch your signs. What I have on the left is 3x. What I have on the right is -8 minus 7. I get -15. The next step is I would divide both sides by 3, and I have a solution. X is equal to -5. And you can't quite see it because I can't quite scroll as much as I normally can. All right, so there's one solution, and later I'm going to check it and see if it works. The other solution is if everything within the absolute value sign is actually negative in value. So I could write that with a minus sign on the outside of it, and inside replace the absolute value symbols with parentheses, right? 3x plus 7, close parentheses, equals -8. I know how much you love minus signs. I see I have one here, and I also have one there. So from your point of view, I could divide both sides by -1, or I could multiply both sides by -1. Either way, those minus signs cancel, and we're left with 3x plus 7 equals 8. I didn't bother writing the parentheses because I'm in a hurry, right? You're in a hurry to learn. Good combination. Now I'm going to solve for x. I would choose to subtract 7 from both sides. This gives me 3x is equal to 1. Now I would divide both sides by 3, and I have my solution as x is equal to 1/3. Of course, I make mistakes every day, and so I would go and plug this back into the original equation and see if it checks. The first one was x equals -5. 2 times -5 is -10. -10 plus 3 is -7. So I would say I made a terrible mistake someplace, huh? 2 times -5 is -10. -10 plus 3 is -7. Oh, I'm looking at the wrong problem. See, told you I make mistakes. Okay, let me plug it into the correct problem. 3 times -5 is -15. -15 plus 7 is -8. The absolute value of -8 is 8. This says I need to have it equal to -8. 8 is not equal to -8. And therefore, no, this doesn't work. As tempting as it is to say, well, it's just a minus sign. Looking at the original problem, and here I'm going to show you the book. When you look at this, and maybe I can even pop in the Zoom a little bit. Yeah. The absolute value can never be negative. It can be 0 or greater than 0. But it is mathematically impossible for the absolute value of anything to work out to be less than 0. So letter C has no solution. I could check the other one if you like. I can put in 1/3. Let's see. 3 times 1/3 is 1. 1 plus 7 is 8. Absolute value of 8 is 8. And 8 is not equal to negative 8. So there's no solution. That's what you would have to say here. No solution for the example that I randomly picked. Okay, I am going to do one more. And I see on the next page, 5 ABCD. I'm going to just randomly pick number 5D because it looks like it's a fun one to do. So 5D from activity 2.2 says 35. Let me undo this and get to where you can see it. 35 is equal to 5 times the absolute value of the quantity x plus 6 inside absolute value signs, and on the outside, minus 10. Now, mathematically, I would say, look, this thing is shifted to the left 6 units, and then it's stretched by 5 units in the vertical direction, and then finally the whole vertex is translated down by 10 units along the y-axis. But let's get there in the slow way, right? So we want to solve each linear absolute value equation. I want to solve for x. My first choice would be to add 10 to both sides. So on the left, I have 45 is equal to 5 times the absolute value of x plus 6. My next choice would be to divide both sides by 5. 45 divided by 5 is 9. 5 divided by 5 is 1. That's why we chose it. And on the right, I have absolute value of the expression x plus 6. Great. I'm making great progress. When you are solving for absolute value, there are two possibilities. Either the number inside the absolute value is positive, or it's negative, and you're going to take the negative of that number to make it positive. So I'll do the first one. Let's say that the number inside the parentheses works out to be a positive number. So 9 is equal to x plus 6 without the absolute values. I choose to subtract 6 from both sides. 9 minus 6 is 3. X equals 3 is therefore one of my tentative solutions. For the other one, 9 is equal to what might be inside the absolute value symbols might all be negative. So I put a negative sign on the outside, write it as parentheses instead of absolute value, and go x plus 6, close parentheses. And now I solve for x. You can use the distributive property and write this as 9 is equal to negative x minus 6. Or you could divide both sides by negative 1 and say negative 9 is equal to x plus 6. Either way, mathematically, these go to the same result. In this case, I would subtract 6 from both sides. Negative 9 minus 6 is negative 15. So there's one solution. If I went this way and solved for x, I could add 6 to both sides and say 15 is equal to negative x, and then multiply or divide both sides by negative 1, and that leads to x is equal to negative 15. The same solution. So the order that you do the math doesn't matter as long as you don't break the rules. Of course, as we learned in my last example, you better plug this in and see if it really works in the original equation. So we'll take the first one that says x equals 3. 3 plus 6 is 9. Absolute value of 9 is 9. 9 times 5 is 45. 45 minus 10 is 35. This checks. Now I'll try the other one. I'm going to plug in x equals negative 15. Negative 15 plus 6 is negative 9. The absolute value of negative 9 is positive 9. And then everything else is the same. So 5 times 9 is 45. 45 minus 10 is 35, and it checks. Ta-da! Okay, I am going to stop this right now, and you guys consider this as a little bit of guidance help that I didn't give you during class time to help you with your homework.